Hello and welcome for attending this live stream. We're going to talk about some interesting things regarding infrastructure versus development and the early stages of development. So be tuned in and make sure to comment so we can get your questions, etc., and answer them probably by our panelists today. So in this talk today, we will kind of cover the infrastructure sides versus the developer side of thinking about new apps or development of apps. Uh, while building an app, you should focus on the growth of the app, but also the growth of the company, right? Because as you think about the future of development, you see a transition from a developer's perspective to more of a infrastructure perspective as it grows, as it scales. So, with that growth happening, you also see a growth in responsibilities. So, essentially, you have a responsibility towards your clients, towards your team, towards the law. So, you have a lot of things to cover and think about in those early stages. So I'll introduce our panelists today. Frederick, please introduce yourself and your relationship with the infrastructure world. Then Rupus will take on the developer world casting later on.
Yeah, thanks for having me here
Yeah.
in Finland. I'm from Sweden, and I'm actually the infrastructure guy here today. I've been working with in the IT industry since '94, and mainly then with server storage, networking, internet security, telecom. So I actually celebrate 30 years this in June, I think it is. So thanks for that. So started out with Cisco 30 years ago. It was kind of a little bit smaller company at that time, but stopped with infrastructure. So and since 2007, I've been actually building cloud services. And that time it was Amazon. We looked at how the business model looked like, and then I build actually more infrastructure as a service when it comes to cloud. So selling like server capacity, storage, backups, communication on tap, and that's what I'm doing today. I'm the founder and CEO for VMAR, and VMAR is a managed service provider in Sweden. So we have our own data centers and deliver services, mainly in Sweden, of course, but we can actually, it's cloud services we can deliver to the one who needs those services. And it's, as I said, server storage, container services built on Kubernetes, and we are also internet service provider. So again, I'm the infrastructure guy, and I have also seen what a bad written code can do to infrastructure. So hopefully I can give you some advice today about that.
Super. Rupus, can you please introduce yourself and your more of a self-hosting perspective or developer perspective?
Yeah. I work for 46 Elks since 2018. I'm the IT operations manager there since a year. My background is that in my teen years I was doing lots with computers and setting up servers and stuff for myself, and then also teaching myself to code, and then also going to school for coding. So 50-50 self-taught school. And I will be representing the more developer side, as I both know software development, but also I prefer self-hosting, but can see both sides. So I'll represent self-hosting and developer side in this conversation. Yeah.
So it's a world where self-hosting and the cloud is your friend. We're not talking about versus or opposites. You should use both, right? So that's why we're brought these two together now to kind of piece those worlds together and show how it should work. A tiny bit about me. So I've been working for 46 Elks since 2022, working with telecom operators and quality assurance. So that's just me. So, We're okay. Cool. We have something to talk about then. Super. So yes. So are there many developers here today with us, and are you perhaps in a situation where you are starting on something, developing something in its infancy, or perhaps a bit more? Like if you have, like you can raise your hand or like talk about it later, I guess. Yeah. Okay. We'll talk about it later. So yes, Frederick, can you please bring up the first slide where the developer phase of it we have? Yeah. So now let's focus on the developer perspective first, and this first stage is usually a bit unstructured sometimes, right, Rupus? So we have you here to cover and also to perhaps others in the room can be engaged and in this development side where there's more app focus stage of development, right? So without delving too much into infrastructure. So the thing here is, and I would like you to go more into it, is the perspective one should have when starting off a bit. So
So there's a lot of choices when choosing how you want to develop your applications. One of the most obvious choices is your programming language. I tend to prefer memory-safe languages, and I think most people do nowadays. Not using C or C++, but using Rust, Python, Go. I know you like, and yeah, or Ruby. Yeah, those kinds of languages. They are sometimes, like Python and Ruby, are slower than Rust or Go, compiled languages. I think you should choose the one that you are most familiar with, and also that you think you can get. If you're looking to employ people, you're probably gonna want to choose a language that you think many would like to work with. Developer satisfaction is a big thing nowadays. The developers want to use the tools they like. So Python, for example, right now is a pretty good choice. Many people do Python. They learn Python in school. But you also have to think about what is your application going to do. Is it going to be very compute intensive? Then you probably do not want to use Python or Ruby. If it's only I/O, like our API is mostly just I/O, gluing I/O together, gluing different tools on the server together. Python works fine. We've used Python since 2011 for pretty much all of our platform. It takes thousands of requests per minute and sometimes seconds. Fine. So IO-bound applications like APIs, probably fine, but some APIs can be compute intensive, and then should look at some compiled language. But I would also always recommend choosing a memory-safe language. If you're not very familiar with C or C++, and you might be able to do something better in C or C++ than with your Python or Go. Yeah.
Freddie, could you please share your vision of this first stage from an infrastructure perspective? Or
Yeah, I've seen it. It's, I mean, you have an idea as it's on this picture, and we see it's very easy to just register an account and register a credit card. And these hyperscalers are the most popular, I would think, AWS, Google, and Microsoft Azure. And you don't actually think more about it because you have all the tools you need to get your application up and running. So that's what we see today. But also the topic today is that we want you to maybe think a little bit longer, think about tomorrow. It's not just about the user to have an application that works. There is a lot else to think about, and a lot to think about when it comes to platforms and infrastructure. So that's my
yeah, we'll get more into the specifics of it, but yeah, from my perspective, the first stage is always like the speed of growth, and the main motivator is for getting the MVP going and to have it working rudimentary. So yeah, usually tend to rely on the things you know best,
Yeah.
and that can be a good choice or perhaps not. But we'll delve into that a little bit later. Yes, but now, Rupus, let's perhaps go through the stages we have as an early development in the second slide here, or like this part of development. So you can perhaps comment on the choosing of high performance or slow and fast programming languages, as you kind of already mentioned, and optimized languages for growth and processing cycles and everything.
Yeah. I think as I said, choice of programming language it's what you're familiar with is probably the most important thing, and then you can make. Computers today are so fast, like they are immensely fast. So if you're not doing something very esoteric or academic, like that needs lots of compute performance, like maybe AI, machine learning, then and also machine learning, Python has lots of libraries for that, written in C and C++ and Rust. So for the most part, Python is probably fine for what you're going to do. And I think that's the most important. You choose something familiar, and then you keep it simple. Stupid, the KISS principle. Like if you keep your application simple and try to avoid complexity as much as you can, you will probably be able to do anything with whatever programming language you choose. So it's easy to overbuild in the start, like thinking about the whole application and what you're going to need, and build lots of structures in your programming language of choice, like setting up classes for everything, using object orientation, and or if you're choosing a functional programming language, still just overwhelmingly using lots of types and abstractions on top of your data, you will create a slow program regardless of the programming language. But if you keep it simple, the processor won't have to do as much, and it will be fast. So I usually write something, and usually it gets complex at start, because you don't know exactly what you are going to build. Like you don't know really how is this going to work, which leads to lots of complexities as you add stuff to make it work, and you add complexity. So I always take a step back and look at, do I really, when this is working, MVP, a small prototype or just a function, when it's working, can I remove stuff? Can I simplify this even more? Do I really need that statement, or do I need that function call? Or can I skip that library? Could I just pull the things I need from that library and put that in my program and simplify it to only do what I need? Then you will make pretty much any programming language go fast nowadays, because computers are super fast. There's no excuse to make a slow program today, I think. But also, like program language that you like, you have some experience with Go, not yourself but your team, and I think Go is a good language for that, because it kind of forces you to keep things simple. It doesn't have generics. It's very simple. The syntax is very very basic in a good way. Like it's clear and pretty much forces you to keep your program simple. If you try to write something complex, you will feel it very very quickly that this is starting to become difficult to grasp. So you will want to do something simple. That's your experience as well?
Yeah. My team loves Go as a backend language, so they're using it only for backend programming.
Yeah.
So, and also all you said actually. So, and but what we see also in writing code is, I don't know if you mentioned it, the documentation of the code. It's very important. So and how you maintain it over time. But I'm more focused on as you know, the platform part, and then questions like where do you store your data, not only geographically or what media are you stored on, and also how accessible and how available are the services. That's also very important. But when it comes to the hyperscalers, of course, and hyperscalers we are talking about the three we showed, and maybe DigitalOcean and these kind of big clouds suppliers. So, but they are. I mean, the availability is quite good because you can scale it. Um, and I don't know if we jump into security also. That is something that we work a lot with. There is a lot of tools. You are choosing different tools for anything, and how maybe forget about security. And there are a lot of threats today that you need to consider, and that's hard. And you need to consider security in all levels today. So, but you need to have it in your strategy when you actually develop an application. So you know what consequences it can be with different choices.
So from on-premise on one side to hyperscales on the other.
Yeah,
What do you think regarding security? Which
it depends on your competence, I will say.
Yeah.
So if you high competence, very low in the stack, and you know hardware and you patch it, and you know operating system, maybe Linux, and you're good in Linux, and also the internet security part, then yes, it's the most cost-effective way to let's say give an application resources. But if it's not predicted load, then it can be hard, because then you maybe need a hyperscaler. You don't want to care about infrastructure. You just want to care about availability, scalability. Then the hyperscalers are a good choice.
For example, with 46X, we have a pretty predictable load. But every API call to send an SMS costs money, which means our customers probably won't suddenly send millions of SMS messages, because that will cost them a lot of money. So we know, based on how many customers we have and what they've historically sent, we know approximately in pretty good range how much load we should be able to handle. So that's we have our own physical servers and use just virtualization to run our API. So we can well ahead we can see when we are starting to hit the ceiling on performance, and we can easily just add more cores to that virtual machine that needs it. The physical machines, like we usually buy some used machines and just put them in a rack somewhere, and they work fine. Like any Intel Xeon or AMD Opteron processor, fine. Yeah, they are so fast. Like we could probably run our API on a modern laptop or something. That doesn't have the reliability of server hardware, so we use server hardware instead. But yeah, we only have multiple servers for redundancy. We are most of the time running most of our servers on only one server, and only have the other ones for failover hot spares.
But it's very important now that you're monitoring everything on the level. I mean, if you're host your own infrastructure, you need to monitor on disks and everything. That's nothing you need to monitor in a cloud service. Of course, if you get out of storage, but you don't need to check if the disk goes corrupt.
Yeah.
Or anything. So.
But on the other hand, if you choose a hyperscaler, for example, and you could suddenly have millions of users just using the service at once. Say you have a social network or an app or something that's free, and you want you will have the possibility of like suddenly getting on the front page of Hacker News and you have millions of people hitting your server, then you might want a hyperscaler to be able to handle that load quickly. But then on the other hand, you'll have to actually monitor the load. Like, have you suddenly spawned 1,000 machines, and how much is that costing you? So there are other things to monitor. On that.
And that's what we see also. We come to the compliance part, and there we see the money. I mean, we have seen customers that something went wrong, and you need more resources and scale up, and you don't actually see it in the first place. Some see it when the invoice comes, and then it's what, and it may be too high to even pay. So that's something that is, we talk more about it later, but that's something that you need to consider, the cost in this. So yeah, it's it depends on, we say it depends on the application, it depends on how it works with against infrastructure, it depends on how it's going to behave in the infrastructure, and that's really important, and how you think it's going to scale in the future. But if we also look on the compliance part, there is that one thing that we see when it comes to using services in hyperscalers is that you use services that you are locked, then you'll be locked in. That it's hard to move out from the hyperscaler. For example, Amazon. That you use so much services, so to be able to move, you actually need to have too much effort to rewrite the code to be able to move it. And why should you move it? I can talk for Sweden. We see it in Sweden that cost is one thing, and compliance or legal compliance, where you store your data, is one thing, because it depends on what kind of data you store. If it's personal data, then the law between Europe and America differs a lot. So then you cannot have it in an American cloud. Maybe it will be changed in the near future, but that is how it looks today. So that's what we have seen, that customers say that we need to move for maybe some of those reasons. And the answer will be the question from us is like, where is it located today? And in many times they say AWS. And then we ask, maybe we can move it. And then it comes down to what kind of services do you use? And then they have a huge list of services they have picked because, sometimes they say, why? What does it give to your application? But you are locked in, and then you can actually not move out from it. So the answer is rewrite the code or stay. And that is also why these hyperscalers are top 5 biggest companies in the world. Because you stay. They want you to be locked in. So this is also something we're going to talk about. So we don't say it's bad, because they have done a lot for the development, the digital development in the world, but you need to be smart when you choose services in these kind of clouds.
And maybe be restrictive about what you choose. Like think about,
exactly.
Do I really need this service, or could I do without it? Could I use something else? Can I move, if I use this, can I move to another place, or am I locked in here?
And we talk about be cloud native. That means actually that you can move your application. It doesn't matter where you have an account. Of course, it can be complex in some way, but as much you work in that direction, you are more like safe with your application. But we have also the two things more to consider is environment. So you write application that is not taking so much, capacity, because in the future you need to measure how much capacity do your application take, and that's not hard to count, because what the data center consumes, and it knows how much your application is using. So then you can actually say how many bits your application is using. So will be in the. We see some service provider building it in Sweden now. So it will be very important to be able to measure that. And also you have compliance like GDPR, as we talked about, and ISO certifications and whatever that you also need to consider.
On the self-hosting on-premise side, it's pretty easy to know your load. Though, like if you have what the wattage is on your power supplies, and you know about approximately the load of your computer, and you'll know approximately. And if you have it connected to a UPS, a battery backup, it will probably tell you it's drawing this much, and you can check it. We're using 30% load on the CPU approximately right now.
Yeah. You also see it on the server level or storage level.
Yeah. If you have IBM
so it's easy to measure, but you need to think about it when you write your code, so you don't use too much capacity. I mean, CPU or needs you write your application, so you need the fast disks with the low latency. That will also cost you a lot. So that's also something to consider.
Yes. So we talked about these companies that want to lock you in, and it seems as though like a very easy solution. It's really sometimes free, or really costs little at the beginning. But as you grow, it locks you in and creates perhaps issues not only with cost but also with privacy issue, security issue, regulation, etc. So that's kind of the bad side of things. Is there any good developments that these companies gave regarding how you can use them actually?
Yes, I think we have one picture about it. Take this one.
Yeah.
I mean, they have driven the digital development in the world, and also something that we talk a lot about is open source. Of course, you need to be careful when you choose software from open source because it can be a security risk. But we see that this is something even for AWS and Google, that they let the platform, for example, Kubernetes, let it free. I mean, Kubernetes is written in Go. Go is Google's language that we like, you said also, and they developed Kubernetes. Google did Kubernetes. Everyone is familiar with Kubernetes, or it's for orchestrating containers. So if you have let's say Docker runtime or containerd runtime or whatever, you can orchestrate the containers with Kubernetes. But they developed it to be able to easier move from the other clouds into Google, but they let it free. So Kubernetes today is actually a good platform for containers that you can be cloud native, and you can order it as a AKS. It's the Amazon service. AKS is Azure Kubernetes Service. GKE is Google Kubernetes Engine, and then you have Elastic Kubernetes Service in Amazon. So you can actually order these services in all the clouds, and if you deploy your application in Kubernetes, you can actually move it to any cloud. And also you can have Kubernetes on-prem. You can have Kubernetes in our data center. We have Kubernetes services. So I can say VMAR, the company I belong to, we are actually in the middle between on-prem services, you build your own, and the hyperscaler. So we are more the local service provider for these kind of services. And as I don't know if you use S3 as an API for storage today. Do you use it, anyone? And S3, you know what it is? Yeah, it's an API that Amazon has developed for for the programmers to handle storage, object storage. But they also let it free. They are still developing it, but everyone can actually use it. So all the big storage providers today are S3 compatible. So you can actually, when you then write your code, if you write it like containerized, of course we say it should be stateless then, because it costs a lot to have persistent storage in Kubernetes. It costs a lot of resources. But if you put the content in S3 and maybe have a database, if you don't need to scale out database, you have it as a virtual machine or whatever, then that's the only thing that may be hard to move, but otherwise you're like cloud native. And also we have, this is actually, I'm gonna show it, but this is application that I like. Have you heard about Rancher from SUSE? With Rancher, it's like, do you have heard about OpenShift from Red Hat? More common? It's more like administrating your container platform. But with Rancher, you can actually, we use it for administrate all your Kubernetes cluster. It doesn't matter if it's in Azure or on-prem or in other data center. And with the same software, you can manage all your clusters. And this is also open source for free. So you can actually get the functionality of a hyperscaler. Not, of course, it's very expensive to build, so you can scale out to eternity. But the tools for it is there, so you can use it. And we have customers that have maybe the test and development cluster on-prem. They have a staging cluster at a local service provider, and then they have production in Azure, for example. And also, it's if you need more resources, you can actually, when you're out of resources, you can start the application in the cloud that you have a subscription.
Yeah, from my side, then I'd say like you still need to think about if you need this.
Yep.
Like it's another very complex layer of software that you will dependent on, and another software you have to learn and master. You can also just spin up your software in a systemd service on a Linux machine.
Yes.
You have to know how to do that, but you also have to know how to use a Kubernetes cluster. So it's different things, and if you don't need that to scale out quickly like Kubernetes can, you maybe need to set up another server for redundancy sometime, or you need to move one of the servers to another more powerful server, but it's like something you do sometimes like every other year or something, then you probably don't need Kubernetes. You can be fine without it, and you will have a lot less complexity in your stack. It's still like you have to think about, do I really need this?
Yeah.
But the answer can be yes.
Yeah, the answer can be yes. And then you not need to use hyperscalers to get these services. That's actually the what I wanted to say out today. And but that's right. Kubernetes can be quite hard to maintain. So you need to have, if you do it yourself, you need to have the competence for it. And you say maybe it's just I have Docker. I use Docker, and then I can handle it. But then when you will scale out, you use Kubernetes for orchestration. So, but many times you don't need it. But this is some example that we want to show about these hyperscalers, that they give out their good technology as an open source. So
nice.
And I mean, S3 is many developer uses S3 today, and many developer thinks that S3 is Amazon. Yes, it is Amazon, but also there, when it comes to cost, it's not so expensive to store the data in these clouds. But if you are chatting with the storage a lot, or if you're collecting data from the storage a lot, then it costs even more. So that's also something when you need to think about how your application will act in these environments. So,
You could show the picture, which is very nice, from like from
yeah,
everything in the cloud to chaos to.
Yeah, I like this picture. It tells a little bit about the truth. I will say it's a cloud journey, and in the beginning, some companies or organizations say that we're going to move to the cloud, and they had strategic that we move everything to the cloud.
Yeah.
So it doesn't matter what kind of application, what legacy you had, we shall move it to the cloud. And you didn't get fired for taking that decision, actually, because it was the right decision, everyone says. And we get away the operational cost, and it was quite high in many companies. But yeah, it was good. New business model. We pay for what we use. It's simple to just start up new services. Developers are happy because they get all the services they need when they want to develop the application. And of course, it's scalable. As we say, it's very expensive to build scalable infrastructure when it comes to hyperscalers. But after a while, we saw that the cost was rising, and when you're starting to think about moving away, you are locked in because you have actually picked services that locks you into that specific cloud. Getting complexity and the competence is getting more expensive also, and hard to get hold of those type of skills when it comes to Amazon and Azure and Google. And also we saw some security issues because you didn't have any control of what's happening in the back end, and you maybe have lack of competence in the beginning, how you should secure your environment. So.
Yeah, it can be very difficult. Like I had to set up an S3 bucket at Amazon for the first time a month ago or something.
Yeah.
And it's to actually understand the security model of Amazon services is a whole thing with the IAM services. So getting it right is not easy because they built it for it's built for everyone, every kind of service ever, which makes it also that the tools to actually set this up in a secure way is also impossible to understand fully.
Yeah, that's right. But now we see what's happening. Use it smart. Use the cloud smart. We talked about Cloudflare here and say, use some services very good in Cloudflare. And that's the same in all the clouds. Many uses Microsoft 365 today, or I will say everyone almost.
Yeah.
Not you, but.
Yep.
And that's actually a good service from Microsoft that brings you the tools that you need. So use the right services, and if you have competence and predicted load, I will say that the most cost-effective is to build it on-prem or use a local service provider. So
Nice. Super. So that's like the journey from chaos to
now from cloud
everything
first,
in the cloud chaos, and then
to be cloud smart.
To be cloud smart. That's nice. Yeah. Yes. We heard the perspective from you, Frederick, from the infrastructure, and
Yeah.
you, Rupus, from the developer side. And if anyone,
I can say that there is now, you talk about now you need to have a multi-cloud strategy instead in the company, and the multi-cloud strategy is actually to be cloud smart. So
Have a plan for moving between clouds, or
yes, and take all this we have talked about in consideration. And also what we see, I can talk a little bit about that also. It's edge computing when it comes to AI and these things. We haven't been think about talking so much about it, but we see that you move some load closer to the data to be able to process the data cheaper before you send it into the cloud, and then you send the relevant data into the cloud because it's cheaper to have this edge computing doing a lot of the jobs. So
yes. Great. Does anyone have any questions, perhaps, or like wants to clear something out in a sense? Yeah, go ahead.
Yeah, I think you talked a lot about like from the perspective that this is the obvious choice to be, I don't know, be able to switch between providers and stuff like that. But I mean, it's a big cost to also prepare those things well, and instead would be much like, especially if you want to move fast, you need to maybe utilize these lock-in providers, and it's worth being locked in for the speed.
yeah, then you have to be prepared for that and know that you are going to be locked in and maybe have to rewrite it when the time comes.
or have a plan.
Yeah, so you see,
Or even have the plan is
Yeah.
like it can also take times, or I mean, depending on what kind of plan it is.
Yeah, but I think you said it. It's more like look at the service that you choose in that specific cloud. Is this something that you actually need for your application? And if I choose that service, is that something that I can buy from another provider, or building myself? So you're not, need to do so much effort to rewrite to move that function away.
it won't take so much time to evaluate whether this service is actually going to fit you or if you actually need it. It's easy to just like see, oh, this looks nice, I'll try it out, and then you have it in your app, and now you're locked in. But if you actually just before choosing to use something, you take a step back and think about, is this something I really do need? Can I do it in some other way with other providers or myself? Or
Yeah, and also we don't say that these hyperscalers you should not use it. You should use it.
Yeah.
But
If
in
you
a
need.
smart way.
Yeah.
And for example, if you start use Amazon S3, it's not so if you don't put a lot of data in there that you need to collect them. But if you use it as a API for storage content, then it's quite easy to use another like blob storage or whatever in Microsoft. So it's more like you look at the service that you choose, so you don't really. And also, I think Google it,
Yeah.
see if it's a service that is proprietary to any clouds.
I think it boils down to like when you have a hammer, everything looks like a nail. You have to choose the right tool for the job. Like if you can do lots with S3 on Amazon, or there are services that can do lots of things with. The question is this actually the right tool? Like if you start using S3 as a database, you can do it, but you will get poor performance and it will be really expensive. So you have to make sure that is this tool actually what I need, or is there another tool that can do it better for this specific purpose?
We had actually talked to my colleagues. There is a public sector in Sweden right now. They have problem. They choose. I don't mention the name, but they have problem. They choose Amazon, and now they have performance problem and cost problem. how can it be? Both performance and cost, high cost. So, but of course, it's the application is built like that, and maybe in that case, AWS was not the right choice, but in other ways it can be. It depends on.
Or maybe another service within AWS.
Yeah, maybe another service, of course. And also, if your application needs low latency and high IOPS, we say, we're going to talk a lot to the storage layer. It's always going to cost you money. It always, because low latency on storage level is very expensive to produce. So that's also something.
We just stick an SSD into our rack and it's fine.
Yeah, exactly. You can do that.
That's easy.
Yeah.
Nice. Cool. Any other?
A good question. Yeah.
So
Go on.
these days, most of the companies are preferring for microservices. You can say there are social media channels who are basically LinkedIn or Facebooks are basically available 24/7 online, right? So you cannot afford a downtime for downtime. So how basically you see the mitigation techniques about related to the downtime challenges? What should a company should do?
From availability perspective, you mean?
Yeah, downtime perspective.
No downtime.
Yes.
So how to tackle the downtime issue?
Yeah, that's something that, of course, the big hyperscalers are good at, to have the service up and running. But I will say, if you use containers, you can build quite high availability with Kubernetes as a platform. But I'm from the infrastructure side, so I see what you're gonna use there. But if you have actually a virtual machine, a Linux machine, or whatever, then you need to build your hardware available. So if hardware goes down, it shouldn't affect the service or the uptime or the application. And also, that's when it's getting more expensive to build on-prem, because you need to have redundant fibers with redundant internet operators with failover firewalls and all this. So of course, then you need to consider, is it worth it? Do I have competence for it? How much will it cost if I buy the service in a cloud instead? So because then you get all of this.
But there's also a risk with using hyperscalers or third-party services, where if you are using many different services, like you have one service for database, you have one service for compute, you have one service for firewall, if any one of them goes down, your entire application might go down. And then you have lots of different point of failures. While instead, if you have, like us on-prem, we have everything on one server. If one server is up, it's good. And if that goes down, we have another server somewhere else.
Taking over.
Yeah, taking over. We just fail over with DNS and say, no, you do your API request over here. So there are different failure modes for using third parties or your own stuff. And that's the same also with, you mentioned microservices. Like if you use microservices and spread them out, yes, those individual services might have redundancy, but if that doesn't work and your microservice goes down and your other services are dependent on that service, then your whole application goes down. That's something you see a lot with the bigger players. Like I think Google's authentication service went down in 2022 or something. And that was just the authentication service, but the authentication service is pretty important for the applications. It's different failure modes, and you gotta think about what failure modes can I expect with my choices.
Sure. Any more questions or comments? Feel free to ask. Yeah, go.
Was it Rufus?
Rupus.
So you talked a lot about why you like self-hosting, but why did 46 Elks choose to do it?
Because we had the the competence to do it. I wasn't involved in making that choice from start. That was made long before I started. But our CEO who built the code pretty much likes that philosophy of doing things yourself and owning your whole stack and knowing exactly how everything works. And I agree with him. It's if you know your whole stack and you can control your whole stack, it's if you go down, if you have a downtime, you can easily find out what the issue is and fix it. While if you're using some service, you're on their mercy that they go up soon. So that's one reason that just doing it ourselves, we have the full control of everything and making sure that everything's up. And it does work. I'm pretty sure we can't. It's difficult to compare, but I think we have a bit better uptime than most service providers do. But that comes with a lot of work and knowledge, know-how you have to have. Another thing is that me and my colleagues all like doing this stuff, like going into a data center and poking at servers and hardware and doing it, and also managing. I really like managing servers. I think it's fun. So that's also one reason.
Yeah, that was I was guessing a bit. Like it was a lot related to like doing it.
Yeah.
Because I hard to see that from a cost perspective that it would be all the resources needed to be able to do it can be quite costly compared to
it can be costly, but I think also it's when it's just working, it's like you pay for the server space, and you pay for the servers only you pay for once. Like you spend 1,000 euros or something on a used server, and you spend some money, some hundreds of euro on some hardware like disks and stuff, and you just put it in a server rack, pay for that space, which is very constant. It's always the same, pretty much, if they don't hike the prices. But it's what the price is, and then it's a constant cost, and you know exactly what the cost is going to be. Of course, there's cost in like using your time to actually manage them, but I think you will always have to manage your services. So if you use hyperscalers that take a lot of the server hardware and maybe also now with the serverless stuff, you don't have to manage operating systems and stuff like that. But there's still things you have to manage, like using Amazon. You still have to make sure that your services are running on different geographic locations on Amazon, different regions, because Amazon doesn't have redundancy within one region. One region can go down, and they will tell you that if you didn't have your service also running in another region, that's on you. And then you have to monitor that stuff instead. So there's always stuff you have to manage.
And I can forgive that, because if you look at 46 Elks application, you have predicted workload.
Yeah.
And you have a database that you replicate between 2 physical servers.
3.
Okay, 3 physical servers. So they are geographically not connected in a cluster.
Yeah.
And then if you can do that kind of application, the infrastructure part, it will not cost you so much. But when it comes to and also you have like SSD or NVMe disks in one server, then if you can build like that, that's the most cost effective from infrastructure perspective. But many application maybe needs more, and as long as you need like hardware clusters with shared storage, then it starts to get more expensive when you build that, because then you need high performance storage. Will you build it in a hyper-converged infrastructure? What kind of software are you going to use for that? VMware or Nutanix or whatever, and it's quite expensive. Or do you have shared storage, and then you go to HP, IBM, or Dell or whatever to buy these storage cabinets, and then also it's expensive to supply the application with good storage. So it depends on, and in your case, it's a no-no when it comes to cost, because your application fits very good with that kind of setup.
Yeah, our use case,
So,
our application very much works in that
Exactly.
way. Like we only need one computer, and
It can break.
it can break, and we just need to have database replicated somewhere else, and we can just fail over to that. So for our use case, it works very well.
So
But there might be stuff in the future we build that might not fit this use case, and then we, of course, will look at other things. But I think thus far everything we've built, and I think also you can probably build your application to fit this kind of use case. There are of course some applications if you really need horizontal spread of your servers, having them geographically everywhere because you need super low latency. Think Netflix, maybe. You have to have data near the customers because you can't just have one big beefy server somewhere that sends all the data. That's just not feasible. It's impossible. It's too much data. But if you, I think many applications can be built to fit this. You have one computer and you can run everything. You have to be conscious about the choices you make in software, in how you do stuff, how many database requests you make to make it actually snappy. But it's also easier with just having one computer because you have everything local. It's the latency to disk is negligible if you're using SSDs compared to if your application needs to contact storage over the network somewhere. Our latency to disk is less than milliseconds.
Yeah, should be if it's local.
Yeah.
So, but also, if you're taking the next step and need like more, you don't fit in one server and it's availability problems or performance problem, then you actually have maybe in Finland someone like us that give you, have the infrastructure and just give you the virtual machines that you need, dedicated or shared in the shared environment. So then you can actually still pay per month and not pay too much, and you get the same functionality on the infrastructure layer. So that's also next step for your own on-prem hosting.
And I think if we were not people who were interested in actually touching the servers physically, a platform like yours would be a very logical step for us.
Yes.
Or from the start, like just having someone manage the servers for us. Yeah.
So there is a room for all of us.
Yeah.
Yeah. So yeah, thanks. Any more questions or comments? Feel free to comment or ask
Did we get any comments from the
web.
online? No comments.
No comments from
Someone watching, you don't know.
Yeah, could be. We'll see. Yeah, it's available online, so on YouTube you can watch it later on. Well, yeah, thanks everyone for joining. We can mingle a little bit afterwards, and thanks everyone on the live stream for tuning in also. That's it.
Yeah.
Thanks.